Hello friends, good morning all of you. Here I am Gadekar Sachin Pandit. Today we are going to learn about solve problem in PMR spectroscopy, assign the structure of compound with using PMR data. Okay, so first of all, last lecture we are discuss a different type of coupling: vicinal coupling, geminal coupling, long range coupling, as well as we discuss rule of spin-spin coupling, then couple, coupling constant and application of PMR spectroscopy in organic chemistry, as well as solve example. Okay, today we discuss a solve problem by using a PMR data. So first problem here, assign the structure of compound with using PMR data. Example 7th. Its molecular formula is C9H12 and IR 1550 centimeter inverse, 1600 centimeter inverse, and 30,000 30 centimeter inverse, and 2950 centimeter inverse. And PMR signals are given. Signal at singlet 2.2 delta for 9 proton. Singlet at 2.2 delta for 9 hydrogen. 9 hydrogen, it means these 9 hydrogens are chemically equivalent, but they not present in neighboring proton. So that's why they give a singlet. It's the information of PMR data. Then second signal, singlet at 6.7 delta for 3 hydrogen. 3 hydrogen singlet. It means again one give more information. These 3 hydrogens has no neighboring protons. Okay, so only two signal, it means chemically equivalent. These two types of protons are present in compound and they are not chemically equivalent. Okay, so first calculate the dBu. dBu, double bond unsaturation. What is the formula of double bond saturation? dBu is equal to 2 into C, carbon, plus 2 plus nitrogen minus halide minus hydrogen divided by 2. This is the double bond unsaturation formula. Okay, so put the value 2 into 9 carbon plus 2 plus 0 nitrogen atoms, 0 halogen atoms, and present 12 number of hydrogen divided by 2 is equal to 4. So in this compound, how many double bond unsaturation? 4. It means that compound containing 4 double bonds or 1 double bond and one ring and presents a two double bond. Okay, so other case, there are different cases. Okay, so indicate the presence of 4 double bonds. If the compound containing one ring, they consider as a one double bond. Okay, so here possible examples, this is the possible structure: 1, 3, 4 dimethyl benzene. Okay, so these three CH3 groups are chemically equivalent and it gives a singlet 2.2 delta for 9 hydrogen. Benzene ring. Benzene ring consists 3 hydrogen. Okay, singlet because it's chemically equivalent 3 proton. CH3 3 groups are also chemically equivalent, but this sp3 hybridized and its chemical shift is lower. But in ring proton, it gives 6.7 delta because rings is highly desealed. So this is the structure of C9H12 compound. Another example. Okay, assign the structure of compound with using PMR data. Example 8. C8H10O. Okay, so how many double bond present in this compound? C8, put the value 2 into 8 plus 2 plus nitrogen atom 0 plus halogen atoms 0 minus number of hydrogen is 10. Calculated value is 4. It means that 4 double bonds are present. Okay, so benzene ring. Benzene ring 3 double bonds and 1 ring. Okay, so 3 plus 1 is 4 contribution. Here singlet at 2.09 3 protons. Again singlet for 3 protons, it means there is no neighboring protons are present. Second B, singlet 3.65 delta for 2 protons. 2 protons singlet, it means not neighboring protons. Okay, so last C is the 7.25 delta 5 proton. 7.25, it means present a ring. 7 to 8, it's the aromatic ring region, chemical shift. Okay, so singlet 7.25 for 5 hydrogen. It means these 5 hydrogens are chemically equivalent and they are split into singlet. Okay, so assign the structure like this: CH3O CH2 pH. All benzene ring containing 5 hydrogens are chemically equivalent and it gives a singlet. CH2 groups are also singlet, 2 hydrogen. There are no neighboring groups for splitting and it gives singlet. Next example, ninth. Okay, assign the structure of compound by with using PMR data. Here molecular formula C7H8 C7H8. Put the value for double bond unsaturation. How many double bond unsaturation? There are 4. Again, 4 types of double bond may be present and it may be 1 ring in benzene. Benzene containing 4 double bond unsaturation. One is the ring and other 3 double bond. Okay. So given information PMR data is singlet 2.32 delta for 3 hydrogen. 3 hydrogen singlet, it means there are no neighboring proton. Okay. Similarly, singlet 7.17. It indicates 5 protons are equivalent and they are not neighboring protons and it gives a singlet. Okay. Only 2 types of signals are observed, means 2 types of or 2 set of protons are present. One is the methyl and another is the benzene, and calculated structure or predicted structure like this tolling. Okay, So this is the structure of given information. Next, assign the structure of compounds with using PMR data. Example 10th. What is the molecular formula? C3H6Br2. Okay, so in this formula containing halogen atoms, two halogen atoms, bromine, dibromo. Okay, so here quintet at 2.4, two hydrogen. Two hydrogen quintet means presence of four neighboring proton. 4 plus 1 neighboring proton. Splitting pattern, it depends on n plus 1 rule. Means two hydrogens split into quadrate, means neighboring protons are 4. It indicates the CH2 groups are present. B, triplet, 3.65 for 4 hydrogen. 4 hydrogen triplet. It means neighboring proton are 2. Triplet means 3 minus 1. It indicates 2 protons, neighboring protons. What is the double bond unsaturated in this formula? C3H6Br2. Put the value. 2 into carbon, 3 plus nitrogen, there is 0, minus halogen, here 2 Br2, 2 halogens, minus proton 6 divided by 2 is equal to 0. It means that there is 0 number of double bond unsaturation. And like the structure like this, there are two isomeric structure, blue and black. Blue, it indicates CH3 split into triplet, but CH2 split into quadrate, and again 2 Br groups present, they triplet. Okay, so but delta value are same, but blue protons there are different delta value, and black there are delta value are different, because CH3 groups 3 protons signal are not given in our data. Okay, so only data gives a 2 signal. There are quintet 2.4, 2 hydrogen, not for 3 hydrogen. In blue containing 3 hydrogen, triplet. So these information are not given, and they are blue color structure are not possible. But quintet at 2.4 delta 2 hydrogen is possible, like BrCH2 Br. So this black color structure is possible and not blue. So next example, assign the structure of compound with using PMR data. 29th example. Molecular formula is C9H13N. It is the example of compound containing nitrogen atom. Okay, so how many double bond unsaturation? Put the value 2 into 9 carbon plus 2 plus number of nitrogen 1 minus halogen 0 minus hydrogen divided by 2 is equal to 4. Okay, so there are in this formula 4 bond unsaturation, means maybe 4 double bond, maybe 3 double bonds and 1 ring. Okay, so many possibilities. So given PMR signal, 3 signals means 3 set of protons are present in compound. First is the singlet 2.2, 6 proton. 6 protons are singlet. It means there are no neighboring protons. Second, singlet 3.4 delta 2 hydrogen. It means singlet 2 hydrogen singlet. It means no neighboring proton. And fourth, singlet for 5 hydrogen. Again, 5 hydrogen chemically equivalent, it means presence of benzene ring. Connect this information and possible structure like this. This is the possible structure of given data. Next example. Assign the structure of compound with using PMR data. 30 example. 30th molecular formula C3H6Br and I. Okay, so this example is similar like this. Okay, C3H6Br2. Okay, 2Br. Okay, so same electronegative atoms, that's why 2 CH2 groups are chemically equivalent and it gives 2 set of proton and 2 signals. Okay, but in this example, two halogen, bromine and iodine, this is the different electronegative atom. So possible structure is second, black color, because in compound only 3 signals are possible: quintet, triplet and triplet. For 2 hydrogen only, it means presents only CH2 groups. How many double bond unsaturation in this 30 example? 13th example. Put the value 2 into 3 number of carbon plus 2 plus 0 nitrogen atoms and halogen minus 2 hydrogen 6 divided by 2 is equal to 0. So possible structure, blue colored and black color isomeric structure, but given information only for 2 hydrogen, not 3 hydrogen. Okay, so quintet 2 hydrogen, it means 4 neighboring protons are present. Quintet, so that's why they split into quintets. Triplet 2 hydrogen, it means neighboring 2 hydrogen. There are different chemical shifts, delta value. Triplet 3.25, triplet 3.70. What is the difference? Because bromine atoms is more electronegative as compared to iodine, and iodine chemical shift, iodine attached CH2 groups chemical shift is near about 3.55, lower chemical shift, because it's more shielded as compared to bromine. Bromine is de-shielded, so that's why chemical shift is more. Okay, thank you for watching this video. Have a nice day. Next lecture we are discuss new chapter 8, combine for problems of NMR, spectroscopic problem based on UV IR and PMR spectra. Okay, spectroscopic problem based on UV, IR, PMR spectra. Okay, so thank you for watching this video. Have a nice day.